Hello, my name is Chinmay. I'm pursuing BTech in Computer Science in Bangalore Institute of Technology. This PPT is from a ddco project and my topic is handling of multiple devices. Handling multiple devices usually addresses to the core challenge faced by the modern computer systems for handling of multiple devices or different types of devices. It may be from our personal computer to a large network of IoT devices. We must always look after the hardware capability, software algorithm and system architecture before going for handling of multiple devices. Multiple devices. Multiple devices usually refers to different kinds of hardware like computers, printers, and storage devices connected together to perform tasks. Handling multiple devices means using these devices to work together and share information efficiently. For example, a computer might send data to a printer or access files from a hard drive. By managing multiple devices, we can make process faster and more organized. This helps improve productivity and allows computers to perform complex tasks smoothly. Managing multiple devices is essential for efficient operation. Each device has a specific role, whether it is processing data, storing information, or providing input and output. For example, a computer central processing unit processes the data, while the storage devices like hard drives or SSDs stores it. Input devices like keyboards or mic allows the user to interact with the system, and the output devices like monitors and printers display the result. These devices must work together to ensure that the computer performs complex tasks without errors or delays. Efficient handling of multiple devices involves careful coordination where the operating system plays a critical role. It ensures that each device gets the resources it needs, such as memories, processing time, and data bandwidth, without interfering with others. Techniques like polling, interrupts, and direct memory can help manage data flow between the CPU and the devices. Proper device management not only improves performance but also ensures that the tasks like printing, file accesses, data transfer happen smoothly, enhancing overall system productivity. Types of devices. There are different kinds of devices like input devices, output devices, processing devices, storage devices, and communication devices. The interaction between different types of devices is crucial for a system's overall performance. Input devices such as keyboards, mic, scanners allows the user to send commands or data to the computer. These devices helps to translate physical actions into the data that the computer can understand and process. Output devices like monitors, printers, and speakers then take the processed information and present it to the user in a readable form and present it to the readable form or audible form. For example, the monitor displays the result of the calculations or graphic, while the printer outputs physical copies of the documents. This constant flow of the data between input and output devices make users' interactions with the computer possible. Storage devices like hard drives, SSDs, and USB drives serves as a long-term memory, storing data and files even when the computer is turned off. The ability to store large amount of data allows the computer to handle everything from operating system to the personal files. Processing devices, mainly the CPU, carry out the necessary computations and logic required for any task. The CPU interrupts instructions, processing data, and controls other hardware components. Finally, communication devices such as network interfaces and wireless adapters enables computers to connect to the internet and other systems, facilitating the sharing of the data and remote access. In well-functioning computer systems, these devices work in a harmony managed by operating system, ensuring that the tasks are completed efficiently and the system operates without any issues. Managing multiple devices in a computer system involves more than just plugging them and using them. One of the main challenges is compatibility. Devices often use different communication standards, ports, and protocols, which may not always be compatible with one another. For example, one device may use or require USB 3.0 connection, while the another might not support USB 3.0. They want USB 2.0. Similarly, different devices might need different types of softwares or drivers to function, which can lead to conflicts or errors. This can be particularly problematic when adding new devices to an existing system, as a new hardware might not always be compatible with the old software or operating system, requiring updates and replacements of drivers. Ensuring that all the connected devices are fully compatible with the system is crucial for the smooth operation and can often require manual intervention to resolve issues. Second is resource allocation. A computer has limited resources such as memory, CPU processing power, and input and output bandwidth. When multiple devices are connected, the operating system must efficiently manage and allocate these resources to ensure optimal performance. For instance, if the system does not allocate enough memory to a device, it might slow down and cause errors. As the number of the connected devices grows, the demand for the limited resources increases, and ensuring each device has enough resources without causing system slowdowns or crashes becomes increasingly complex. Lastly, driver management can be one of the most time consuming aspects of the managing multiple devices. Each hardware device requires a driver, which is specialized software that allows the operating system to communicate with the devices. The drivers ensures that the devices function correctly and make the most of its capabilities. However, keeping these drivers up to the date can be challenging. New versions of drivers are released regularly to improve performance or fix bugs, and older drivers can become compatible with the new operating systems, causing drivers to malfunction. Additionally, if the device stops being supported by its manufacturer, it may not receive importance updates, leading to the potential security risks or performance issues. Despite of these challenges, effective device management is essential to ensure that all devices work together efficiently and that the computer system as a whole remains stable and productive. Device management in an operating system. Device management in an operating system helps control all the devices connected to a computer, like printers and keyboards. It makes sure each device works correctly and does not cause problems with others. And the operating system uses the drivers to help the computer to understand how to use each device. In short, it keeps everything connected to a computer and works very properly and smoothly. Managing multiple devices in a computer system require careful coordination to ensure everything operates efficiently. One common technique is pooling, where the computer repeatedly checks each device at regular intervals to determine if it needs attention. While this method is straightforward, it can be inefficient, especially when dealing with many devices. The computer spends time checking all the devices even when none of them need any action, which can lead to wastage of processing power and slower system performance. An alternative to polling is interrupts, which allow devices to notify the computer when they require attention. Instead of constantly checking each device, the computer can focus on other tasks until the device triggers an interrupt, signaling that it needs processing. This technique improves efficiency by allowing the CPU to work and other tasks until an important event occurs. Another powerful technique is direct memory access, which allows certain devices such as disks, drives, or network interfaces to access the computer memory directly by passing the CPU. This direct memory access speeds up the data transfers by allowing devices to move large amount of data without involving the CPU, which can be occupied with other tasks. This reduces the load of the CPU and improves overall system performance, especially when transferring large files or handling real-time data streams. DMA is commonly used in applications like video playback, disk inter input output, where large continuous data transfer are required. These techniques, polling, interrupts, and DMA, work together to optimize the management of multiple devices, ensuring that the system runs smoothly and efficiently even under heavy workload. Real world applications. Real world applications include printer queues, network devices, input output devices. In our daily lives, we often use many devices at once. For example, in office, the printer queue helps organize print jobs, so they print in an correct order. Without it, prints gets mixed up. In Network devices like phones, computers, the router manages the data flow, ensuring all the devices stay connected and work properly. Also, in Atlas, like input and output devices like keyboards, screens, need careful management to prevent errors when sending or displaying information. In all these cases, managing multiple devices helps everything run smoothly. So, in conclusion of our topic of handling of multiple devices or managing of multiple devices, managing devices efficiently is crucial for a smooth computer and system performance. Looking to the further or future, device visualization will allow to run multiple devices on a single system, saving space and resources. Cloud-based management will make it easier to control devices from anywhere using the internet. Additionally, the IoT, that is Internet of Things, will connect more devices to the internet, making everyday objects smarter and more interactive. These advancements will make the device management more flexible and powerful, improving how we use and interact with the technology. Thank you.